Hello, everyone. Okay. So, yeah, yesterday we finished this getting started Mobx state 3 tutorial. Let me do one thing first. Yeah. But yeah, of course there is more different things to learn about it. Like, I don't know, we haven't tried async actions or persist data, etc. But I think we will dive in depth into it when we will build in some up. For now, I want to watch, like for today, I want to watch this video, Reinventing Mobx. Basically, it's I found it from the Jaman. Jaman is the CTO and founder of Infinity Red, and also maintainer of this Mobx State 3. And his point on Twitter was like, he replied to someone that Mobx is too magical, so you can't use it because you don't understand how it's works. It's black magic behind it. And Jaman suggests to watch this video. It's a bit old, like 2019. Yeah, and maybe, yeah, basically I have the story about it, like it's I feel the same about the Redux back in the days, and when I watch the video of Dan Abramov how to recreate the Redux, my understanding of like jump to another level, and yeah, I feel more confident about Redux after this. So if you have like time and will to dive deep how the tools you are using, libraries working under the hood, it's could be really helpful. So yeah, let's just start watching. Maybe we can speed up.
Hello, thank you for being here. I'm very excited. First time at the React Live, also first time on the React Live, first one of many more. So, who am I? My name is Max. I'm principal engineer at Dazan. Thanks for the introduction. And I did grow up in Rome. I was born there, and then I moved to London 4 years ago. You can find me on Twitter _@maxgallo or on maxgallo.io. So what's the agenda? What are we going to talk today? So first hit, immediately, we're going to see why reinvent. What does that mean? And after we learn why we're doing some things, we are going to reinvent it, like in live coding, reinventing. And then we're going to add React into the mix, because I'm pretty sure most of you are familiar with React and Mobx all together, and you may be curious to see what's going on behind the scenes. So why reinvent?
Yeah, I hope sound of the video is good on stream.
Exactly.
Okay.
This is a picture of me when I was 9 years old, and I had my particular way of discovering things was by taking things apart, by dismantling them and finding out what was inside. I wasn't pretending to understand everything that was going on inside. I remember VHS recorder, I had no idea what was going on there, and I wasn't even able to put it back together, but I was learning, I was curious, I was doing something. And today I want to bring some of that curiosity to this stage. I want to borrow some of that curiosity, because not only we're going to see inside some of the things we use every day, but also we're going to reinvent our own version. So one step forward from 9 years old me. So reinvent Mobx. Time for live coding. So on the left hand side, you can see a white part, which is when I'm going to write. On the right hand side, you can see a dark one.
Okay, what we see here, there is Mobx. We have observable and autorun. We create album observable object. Then we do autorun. Each time the count is changed.
Dark one, which is simply node running what's on the other side. So let's see what we have here. First of all, we are importing observable and autorun. This is a Mobx example running in Node. And we're importing two things, observable and autorun. We are using observable straight away, immediately here. And we are using observable in a way that it's generating one observable called album from an object. Great album. But by the way, this object has a bunch of properties, and the output, album, is an observable. Then we have autorun. What is autorun? Autorun has a little bit of black magic going on. So the first thing that it does is that it immediately runs the function. So when you see it synchronously, boom, the function that you pass here inside gets run. So it gets fired immediately. And after that, it will re-trigger that function every single time one of the observable in that function changes. What does that mean exactly? It means that if I try to change some of these observable properties, like doing album play count 1, because maybe I'm listening, then I'm listening even more. And when I do that, what's happening is that Mobx is re-triggering this whole function. And on the right-hand side, you can see that I get my count 0, which is the first run, then reaction, and then count 1, count 2, count 3. And this is like very basic example of Mobx. So observable, so far, we don't know exactly what's going on. Autorun, a little bit of black magic, but re-render stuff when observable properties change. So what does that mean, reinvent? It means that I'm going to get rid of this stuff, and I'm going to write my own version. So function observable, and inside observable here I'm passing an object called target object, and then I'm defining autorun. This is called runner. I want to start from autorun as
So yeah, let's do the same. Let's so reinvent Mobx. Maybe Bun can help me. Okay. Not just failed, but yeah. So Bun add Mobx. And let's try to copy this example. So we want observable, not action, but autorun. Yeah, I want Praetor here, so Bun and now let's restart our new Vim. Did anything? Yeah, Praetor is work now. Okay, so okay, let's ignore this one for now. Const album. And yeah. Now let's do auto run. And album. Play count. Console log. Reactions. Set timeout. So something like this. Let's add run command. So ban indexed, yes, I guess. Let's try. Yeah, I think this, since this talk is a bit old, it's required to run modification in action, like, I don't know, run, I don't know, LSP doesn't work here for me for some reason. I don't know if we've just restart. Okay, autocomplete doesn't work, but it's not really needed here. Anyway, basically it's work. We see count 1, 2, 3. And next step to create observable and outrun functions. So let's do this function target object and function, I don't know, something like this.
Engineer, software engineer, we like to have big problems and we split those into smaller problems. So I want to split my autorun function into 2 smaller problems. First problem is I need to find out which are all the observables properties I'm accessing, because if I know that, later on I can try to do something on those. So my first step is find observables. The second step is actually rerun the runner for every time one changes. Yes, I spelled every in a very bad way. Rerun time every one changes. So we have a list of things that are changing, and after with that list, we're going to rerun the autorun function when one of those change. So let's start with the first one, finding all the observable. So what's going to happen here is that, first of all, I'm going definitely to run the function. So as I tell you, first thing that autorun does synchronously, it runs the function that you're passing. So
find first problem is find observables and sorry, it's wrong place. So we want let's rename it so don't confuse ourselves. And allow for skip down level, strict false, composite, no emit. Okay, this is fine. So we run the runner.
no big news here. But while I'm running it, I actually need to do something for my find observable tasks. So how can I find all the properties I'm accessing? So in JavaScript, as in many other languages, one way of accessing properties is through getters and also setters for setting. So somehow I need to be in the middle between the consumer, which is anyone that is doing album.name or album.play count, and the album itself. I have to be in the middle, like I have to be on every getter every time I try to get some of those properties. And in ES6, we got actually this function out of the box, and it's called proxy. So proxy is something with this particular syntax, which sits between the consumer, so someone that wants to.
Okay, so JavaScript proxy. Let's take a look. Mozilla docs as usual. So yeah, the proxy object enables you to create proxy for another object, which can intercept and redefine fundamental operation for that object. The proxy object allows you to create an object that can be used in place of the original object, but which may redefine fundamental object, like getting, setting, and defining properties. So getting, setting is something we needed in our example. Proxy objects are commonly used to log property access, validate format, or sanitize inputs, and so on. You create a proxy with two parameters: target, original object which you want to proxy, and handler, an object that define which operation will be intercepted and how to redefine intercepted operation. So here is example. We have an object, message1, message2. We have handler object, and we basically pass two objects to proxy constructor and getting proxy. Now we have access to the message one, a message to properties of target object in proxy. Then to customize the proxy, we define function on the handler object. Okay, so we add get target probe and receiver. Here we provided an implementation of the get handler which intercept attempts to access properties in the target. Handler functions are sometimes called traps, presumably because they trap call to the target object. The very simple trap in handler 2 above redefine all property accessor. So for any prop we return vault. So when we console log proxy, it will return something different. Okay. In this example, we just modify I don't know what is reflect get. But anyway, let's assume this. In this case, we just modifying the probe message 2. So we'll get hello from message 1, and from message 2 here we will get vault. The reflect method still interact with an object through object internal method. It doesn't deproxify the proxy if it's invoked on a proxy. If you use reflex method within a proxy trap and the reflect method called gets accepted by the trap again, there may be infinity recursion. So as I understand, we just avoiding the recursion. If we do target and get prop, it will invoke handler again and again, so it will be infinity loops. Now reflect allow us to get the prop of the target, but not invoke the proxy handler again. So terminology, the following terms are used when talking about the functionality of proxies. Handler, the object passed as the second argument to the proxy constructor. It contains the traps which define the behavior of the proxy. Trap is the function that defines the behavior for the corresponding object internal method. Target object which the proxy virtualizes. Invariant semantic that remain unchanged when implementing custom operation. If your trap implementation violates the invariance of handler, will be thrown. So object internal methods. Objects are a collection of properties, however the language doesn't provide any manner of direct manipulating data stored in the object. Rather, the object defines some internal methods specifying how it can be interacted with. For example, when you read object X, you may expect the following to happen. The X property is searched up the prototype chain until it's found. If X is a data property, the property descriptor value attribute is returned. If X is accessor property, the getter is invoked and return value of the getter is returned. Alright. So I think we get the idea here. There's maybe what we need to know is we can trap get, set is extensible, prevent extension, get on property descriptor, define property, has get set, delete, and on case. Yeah, to be honest, I didn't know about proxy before today, and it's always nice to learn something new. Okay, nothing in the chat. Let's move on.
Want to access that object and the object itself, and is able to intercept all the communication that's going on. So how does proxy works in a practical way? So you can pass the object that needs to be proxied, and then you pass another object with get and set, which I'm going to define object value key. And our getter, not big news here, is return object of key. And then, not keyboard event, key. Other than the getter, we have a setter. Setter does object and key, and also have a value because it's a setter. And here we do object.val.key. Yes. Object.key equal to value. So nothing new so far. I'm just setting up the whole thing. Remember, I need to
Okay, it's doesn't look exactly like this, to be honest, but let's try. Now return new proxy get
intercept all the getters. So how do I do that? I'm actually here. I'm in the right place, this line here. And in order to do that, allow me to define something outside called access observables, which is an empty object. And just before the
okay, this is interesting.
runner, I'm going to make sure that my access observable is still an empty object. And at every getter, every time we interact with one of the observables, I'm simply going to do access observable dot push, and I'm pushing the key.
Access observables. Okay. And
Here. So
okay, so just key, no target. But I think the idea each time so if the runner will access observable, or no, let's switch.
So in order to show you that this one is actually working, I'm going to console log access observable. This is going to be an array. So on the right hand side, you see count 0, which is when I run that function. And after, you see the list of all the properties I accessed. No big news so far, but our first task
in auto run. So console log yeah, we see count 0 and then play count. This is interesting.
is actually working. And now, in order to do the second task, I want you introduced to one concept, which is the derivation graph. So derivation graph is a concept in Mobx which connects the observables on the left hand side with the reaction on the right hand side. So it's a graph that connects all the reaction happening, like the autorun method, with the observable. And how are we creating this graph of connection? We do by starting from the reaction itself. So the reaction is the function that I'm passing to the autorun. So I run that function, and I'm able to go through the graph up to the observable values, exactly those things that I was accessing with the proxy and the getter. So if I manage somehow to create this graph, I can move to phase 2. And phase 2 is the same graph, but goes in the other direction. So for phase 2, if one of the observable change, we'll have to fire all the reactions that are connected to that observable. And that's perfectly doable. If you follow the yellow mark here, from observable values to all the steps in the middle to reactions, this is still walking through the graph. So step 1, creating the graph. Step 2, walking the graph in the opposite direction. It feels very complex, but in our case, the graph is going to be just a simple object, so a very basic graph. So I'm going to define const derivation graph, which is an object. And
Okay. Derivation graph. Okay.
this derivation graph is going to be populated exactly here. So when I do access observables dot for each, and for each of these observable, I'm going to make sure, first of all, that derivation graph of key is equal to derivation graph of key or empty object. And then, yes, no. And then I'm going to do push. And what I'm pushing here exactly, I'm pushing the runner. If you remember, the runner is the function that we are passing here.
So we go through assessed keys. And yeah, so we check if the key property is empty. We set the empty array so we can use it as array, and then we can do yeah, push the runner here. So the album is observable. Yeah, I'm trying to understand. So album is actually the proxy. And here we access the play count. Let's also access something else, like album. What we have? Title. Yeah, we have title. If I just access the title somewhere, interesting. Why it says it not exist, but yeah, you see play count is what if I oh, maybe I should put it before outrun. Yeah, you see title is also added to accessed. So this is clear now. So we get the list all accessed. Let's move on.
So I'm creating the graph in this very line here. I'm connecting the keys with the reactions, with my runner. And if I save, nothing will change. Actually, almost few things are broken because I wrote posh. I should write a library code push. So nothing changed because we didn't did the last bit. So we created the graph, and that's awesome. Now we need to walk the graph in case one of the observable property change. But how do I know if something changes? It happens to be that I have a setter here. And if you want to change anything on those observable thing, it's going to go through this setter. So what I'm going to do here, I'm going to do derivation graph, derivation graph of key for each. And for each runner here, I'm going to do runner. I'm going to fire that runner. Yes, on the right-hand side, if you see, it may not be exciting, but it's kind of it is, because we rebuilt it and we saw that the count are finally coming. So let's do a quick recap of.
So yeah, on setter we can do like derivation graph key, just in case. And yeah, it works. So yeah, this is like super simple implementation, I guess. So the graph is actually just not really graph, but just key value object.
Of what's going on. Autorun. First of all, we do collect all the observable properties that we are accessing with the autorun function. After that, we create the derivation graph, and we use the derivation graph to walk the other way around in order to have all the reactions. And that's all I wanted to show you regarding Mobx. And I want to write a little abstraction, and we're gonna need this one later, so you have to have a little faith in me. So let's do a function create reaction, and I'm passing a function called onChange. I'm simply refactoring the autorun function a little bit. Oops, return truck. So I'm returning an object that contains truck that accepts one parameter, which is truck function. And in this function, I'm basically doing everything that was happening inside my autorun function. So not.
So function, okay, create reaction on change, return object track function, and here we just move I guess this should be track function. And so the function receive on change, but then Okay.
Nothing really interesting yet. I'm
Yeah.
changing things to make sure it's still compiling, and this is on change. So
Okay, this is on change. So now it makes a bit more sense. So basically we run the function and add on change. It's still a bit confusing.
So why the hell I am doing here? I'm doing this kind of abstraction because in the auto run I'm able to write the following: const reaction create reaction, and I can pass the runner because this is the function that will get re-render every single time. So if something changes, this is what
So const reaction. Okay.
it gets called. But it also, I'm explicitly going to say reaction.track runner. So
Okay, now
reactions in Mobx are something a little bit more deep down. Autorun, as you saw from this example, are a special kind of reaction. Reaction is much more explicit, like you're tracking this and you want to react with that. Autorun is everything together, but we're gonna see later on how these two concepts, what I'm tracking and what I'm reacting to, could be two different things. So that's it. That's Mobx. So
okay, now it makes sense. So and this is basically the same track and reaction, but in different case, not outrun. Could different things. Okay. Ah, and now we fix it with generics. So takes t and returns t. And album now not an object but the object with title, year and play count.
now it's time to add some React. So how do we add React to this project? I want to write a very basic UI so we can see Mobx and React playing together. So let me define album here as a React component. No. And in this React component, we're going to use the div h2, why not? And we have album.title and then album.play count. Okay, so far, nothing really interesting in this album. And then I need to render this album. And where I'm rendering it, I'm rendering to document, get element by ID. And you have to trust me that there is an ID called root, and I should probably not do that. Okay, almost everything good. I need to add a bunch of stuff. Const react equal react. And then we did use also the render from React DOM. So const react, not react, render, require react DOM. Okay, almost good. There is just one problem, is that I was running something with Node, and Node and this particular example with React, they don't really play together that well. So I'm going to stop this one. Hopefully, I'm going to get rid of this one. And behind the scene, you can see that there is a parcel task running. So parcel is bundling all my stuff together, so I don't have to think about a lot of stuff. And in the corner here, there is a small browser, and which is actually mirroring whatever happens on the code. Is actually my browser, my reference browser. So just to show you that this is the real one, I can actually change it, and it's going to change. Yay! So all good so far. This is React like 101, or even before 101, and we are not really interested into that. So we want to connect React with Mobx. So what we're going to do is we're going to import a method called observer. If you're familiar with React, you already know what I'm about to do. This is coming from a module called Mobx React, and yes,
Yeah,
what did it?
this is actually interesting part. I don't have a lot of time for this stream, so I probably will not start React project for this, but yeah, let's watch till the end.
That was scary. React. So Mobx React is able to connect Mobx with, guess what, React in a way that we're gonna see in a second. So let me define observer album as the observer of album. So, and then I'm going to use observer album here. Observe. Okay. So you're not seeing anything working.
Let me quickly check. Yeah, my camera is not covering the browser in the video, so
Still on the right hand side is still okay, computer 0, no matter if we are actually changing the model of that view, because we have around our awesome implementation, like custom implementation. So let me get rid of this one for 1 second and bring back observable and autorun. What will happen, hopefully, in the corner in the right, is that you see the React component is re-rendering. But what is exactly going on? I'm connecting Mobx, my Mobx state, with the React component, and I'm re-rendering the React component every time something changes in my in my state. That's pretty cool. But if we want to analyze what's happening, I would like to show you the similarity between the autorun that we saw before and what's going on here with React. So autorun, once again, it re-render the function that you pass every time one of the observable in that function change. And if we use the render method as that function, we are actually having a very nice connection between Mobx and React, between your state and your view. And your view is going to re-render on its own. You don't even have to track down who needs to be re-rendered for what, because we are not re-rendering anything. Thanks to the derivation graph, we know exactly all the reactions that we need to re-render. And so how do we translate this autorun album render? Unfortunately, I can't copy and paste that line. It's not gonna work. You have to trust me on this one. So I'll bring back our implementation, and I'll, as you know the drill, I'm getting rid of observer, and I'm defining my own observer. So the function observer, which accepts one parameter, which is in this case I'm gonna call it base component. Function observer return, actually, let's create it. If you're familiar with iOrder component, we are simply wrapping the component that we are passing. We are giving it a different behavior, and we are returning a new component with this different behavior plus the original one. So this wrap component, let me return it before I forget about it. So what's happening inside this wrap component? Inside this one is where we need to create the reactions. So we need to create the reactions. So I'm going to do const reaction equal to what should I do here exactly? There is a problem, because This is a function component, a functional component, so it's stateless. So it will be re-triggered, re-fired every single time the component re-render. And reaction, it's something that should last for the life cycle of the component. So I need to add a state to something that is stateless. So that's why I'm going to use React hooks and the use ref method. Use ref, you may be familiar with it for DOM nodes, but it could actually be used just to store any kind of variable for the whole life cycle of the React component. So use ref, we are creating the reaction here, so that constant is going to stick around for the whole life cycle. Doesn't matter how many times we are re-rendering. So probably need to import use ref, and also, trust me on this one, I need to import use state. Require React. So everything in the bottom right corner is still empty, so still sad browser, but we're nearly there, nearly there. So we have.
So what we're doing here, we create the function observer that takes base component and return the wrapper component, so it's basically a high order component. Then we use ref to create some reaction.
We have our reactions. So if our reaction is not populated, so reaction current is the way that you access, you set, and you get information with use ref. So if it's not set, we are going to do reaction.current equal to create reaction. You can start seeing the similarity between the autorun function and our observer function here, because we are creating another reaction. The difference that now we need something here. That function was a function that will re-render the component every single time we call it. How can I create a function that re-render a component every single time? Again, I need to ask some help from React hooks. So I'm defining use force update. As use force update, which with an initial state of 0, and then I'm returning a function that does set x, not x. It may be basic, but this is actually something that is going on inside Mobx. I would suggest you to have a look at the source code. So this is a trick used to flip the state every single time between 0 and 1, 0, 1, 0, 1, so the component gets re-rendered every time. And these allow me to write force update, which is use force update here, and let's get some space. And inside my create reaction, I can finally write, if I know how to type, I can finally write my force update. So every time something changes in that reaction, I'm going to re-render that component. Almost there, almost there. We are missing the track part. So if we, for a second, collapse this one, and we keep autorun in the view. Autorun is creating the reaction and is also tracking something. So we need to track. What do we need to track? Which are the things we need to re-render the component for? Exactly all the observable that we access through the render method. So let me write output here, put, and output is going to be populated in reaction.current .track. So I'm tracking, track is a function, and I'm passing to track another function where I'm doing output equal to base component, if you remember, is the one that is coming from here. And since all of this is happening synchronously, I can perfectly do return output. So hopefully, when I save this one, yes, so bottom right is working. So my view.
So now let's take a look. We get here, I think it's so obvious. So first of all, we have this use force update, which basically just change state from 0 to 1, and it's force React to re-render the component. Okay. And it's force wrapped component re-render. Okay. Then we create reaction, use ref. we initialize this ref with create reaction and pass the force update. So force update going here as a parameter, so it's on change and it will be invoked here. So basically on change we run force update.
It's re-rendering based on what's happen on the model, and the connection is all here in 15 lines of code inside the observer. So what we did, we encapsulate the original the original component into wrapped component. We created a reaction using the use ref, so we are using something that will last through the life cycle of the component, and then we are forcing the update every time one of the observable changes. And that's all I wanted to show you from the live coding section. So we'll go back here to the slide. That was a lot of code. It was intense, so thank you for the patience. And I want to leave you with a message. If you have something that you like, that you may want to know more, or a library that you use every day, try to be curious. Watch what's inside. Try to disassembling, try to take it apart and watch what's inside that open source project, maybe, because it could be way easier than you think is going to be. And then try to reinvent. Try to build your own leader version, like I did here, to see exactly which are the challenges, which are the tricks.
Yeah, I'm completely with his point about like try to understand what in this library, but let's take a look. I have something to it. So for example, we have Mobx React. It's outdated repo, but or we can jump here. Nope. Maybe there was a link. Oh, okay. Here we are. And now if we look into the source, you can see there is more files that he mentioned, like in 15 lines of code we recreated, so it's not that obvious. Because like when you creating like first step, it's very simple, it's clear to understand, but if you just jump right into the library code, it developed over the years and there is a lot of things coming out. It's happened to any project, like if you even the project you created yourself, and if you working on it several years daily, like full time, it will become more complex because you add in more and more code, more and more details, like handle more and more cases, etc. So we still can go to the source code and try to understand how it works, but it could be really challenging. The maybe best way to do it is to watch some video like this, like which provided some concept, and then when you know the concept, you can try to see how it actually works in this library. I don't know, can we even find here force re-render? So observer, this is observer. Now first line, like, is Mobx injector, what it is? I don't know. Okay, this is just for some warning, we don't need it. Then prototype is prototype of call React component or pure component. So basically this is, I don't know exactly what it's doing, but from output we see it checks this is even class or functional component. So observe my class, observe, so we can check just the functional component. For example, observer light. And it brings us to the index. Observer is come from the observer. Sorry, maybe I need to make it a bit bigger. Okay, I think I'm kind of stuck in the loop. Okay, it's React. Okay, we in React, but this is point us to the observer of React Lite. And this is our observer. And you see there is a lot of code. Not like huge, but it's just first file. We look in this 150 lines of code with all these complex types, but maybe still we can find something here. What I'm looking is this force update implementation he mentioned. Is there anything? No. So use ref. No. So yeah, it's still manageable to understand, but you need to consider that you need more time for this. I think I'm done for today. I will try to run this implementation for the React, maybe not on stream. I'm just it's kind of like different experience. You just watch the code and you see, okay, I understand how it's working, but when you really type it yourself and you try to run, you did some mistakes, then you fix the mistakes, your understanding is jump on another level of this thing. So if you're curious, I recommend you to try it. It's small, simple, so you can try it yourself and you will understand Mobx much better. So let's listen last words.
Do not need a to-do task learning the X and that thing working. And when you do that, you don't really have to think, but you're learning. You do not need a to-do task learning the X and that. If you do the first two things, you're learning automatically. And once you have learned something, please share it. Come to this stage next year on the next React Lab conference and show to everybody else what you did. So disassemble, reinvent, learn, and share. Thank you very much.
Yeah, great talk. It's amazing. Just put some up, put the comment. No, this talks like it's not a million views, it's just hundreds and maybe a few thousand of views, but it's bring your knowledge to another level. So always support people. And for me it's it for today. Thank you for watching. See you tomorrow.